Hi, and welcome to another Dante tutorial. This time I'll be walking you through how to create an aluminum solution treatment through Abaqus, including a thermal model and a stress model. For this tutorial, I'll be using an axisymmetric ring slice that'll be provided in the description. You can also find it within the Dante files. To start, launch Abaqus CAE and click with standard/explicit model. Select File and Save and enter a file name. I'll name this Abaqus Aluminum Tutorial and then click OK. Next, to import the geometry, select File, Import, and Part. Set the Files filter to Step, and then select the provided ring axisymmetric file and then click OK. This should also be available in the Dante files. Switch to the Part Attributes tab, and then select Axisymmetric and click OK. Next, to create an instance, switch to the module to Assembly, and then click Create Instance and OK. Now let's start creating the mesh. Switch to Module to Mesh, and for Object, check Part. Select Mesh and Controls, and then select Quad and Structured, and then click Done. Select Seed and Edges. Box select the geometry and click Done. Under Method, select By Size, and under Buys, select Double. Under Sizing Controls, set minimum size to 0.15 and maximum size to 2.5. Click OK and Done. Select Mesh, Part, and then click Yes. Select Mesh and click Element Type. Under Family, select Heat Transfer and click OK. Switch module to Part, select Tools, Set, and Create. Enter all elements for the name and select Continue. Box selects Geometry and click Done. Switch the module to Assembly, select Tools, Set, and Create. Enter all nodes for the name. Check Node under Type and click Continue. Box select the geometry and click Done. Select Tools, Set, and Create. Enter a monitor node for the name. Check Node under Type and click Continue. Select the upper right vertex and click Done. Select Tools, Set, and Create. Enter Fixed Y node for the name. Check Node under Type and click Continue. Select the lower left vertex and click Done. To create the exposed surface, select Tools, Surface, and Create. Enter Exposed Surfaces for the name and then click Continue. Box select the geometry and click Done. Right-click Model 1 under Model Tree and rename it. I'll name this one Aluminum Tutorial. Select Plugins and click on Dante Model Builder. Set the model type to Thermal Aluminum and then click Create Dante Model. Click Yes and save your progress. Switch to the Materials tab, and for Part Element set it to Ring Axisymmetric All Elements. Select Material as SAL6061, and then click Add Material Section, and then click Dismiss. Switch to the Steps tab, and let's create our steps. Modify the step info cells according to this table. Change the step name to Solution Treatment, the previous step to Initial, and the time period to 3,600 seconds, and click Create Step. For the Quench step, change step name to Quench, and set the previous step to Solution Treatment, and set a time period of 300 seconds before clicking Create Step. For the first Air Cool step, change the step name to Air Cool, the previous step to Quench, and the time period to 1,800 seconds before clicking Create Step. For the Aging step, change the step name to Aging, the previous step to Air Cool, and the time period to 12,600 seconds before clicking Create Steps. For the second Air Cool step, change its step name to Air Cool 2, the previous step to Aging, and the time period to 700 seconds before clicking Create Step. Check Monitor Node and select a Monitor Node before saving your progress. Now we're going to make some of the initial boundary conditions. Switch to the Initial/Boundary Conditions tab, and then click Add Initial Condition/Predefined Field. Check Constant Value and set it to 20 degrees Celsius before clicking Apply and Dismiss. Select Field Type and click Kinetics Mode, and then click Apply and Dismiss. Set Field Type to Volume Fraction of PPTA, and set the constant value to 0.025, and then click Apply and Dismiss. Change the field type to Average Size of PPTA, and then set the constant value to 5, and then click Apply and Dismiss. Change the field type to Average Size of PPTB, change the constant value to 1, and click OK. Click Add Film Property/Amplitude, and then enter Furnace for the name. Check Temperature Dependence, and then right-click on the table and select Read from File, and then click the Select icon. Navigate to the generic HTC data within the Dante files, and then select Generic Furnace Heating.txt. Click OK and OK to read HTC data. Dismiss the CAE message and then highlight all non-numerical data rows and then right-click to delete, and then click Apply and Dismiss. For the next film property, enter Oil for the name, and then right-click on the table and select Read from File. Click the Select icon, and this time select the generic Oil Quench txt file. Click OK and OK to read HTC file, and then highlight all non-numerical data rows, and then right-click to delete before clicking Apply and Dismiss. For Airco, we're going to do a similar process. Enter Airco for the name, right-click on the table, and then select Read from File. Click the Select icon, and then select Generic Air Cool txt, and then click OK. Highlight all non-numerical rows and then right-click the delete and click OK. Click Add Interaction and set the HTC versus temperature to furnace. Enter 540 degrees Celsius for constant ambient temperature and then click Apply and Dismiss. Set the step to quench, set the HTC versus temperature to oil, and then set 65 degrees for the constant ambient temperature, and then click Apply and Dismiss. Change the step to air cool, and then for the HTC versus temperature, set that to air cool. Set it to 20 degrees Celsius for constant ambient temperature, and then click Apply and Dismiss. Change the step to aging, and then change the HTC versus temperature to furnace. Change the constant ambient temperature to 220 degrees Celsius, and then click Apply and Dismiss. Change the step to air cool too, and then change the HTC versus temperature to air cool. Set 20 degrees Celsius for the constant ambient temperature and click OK. Now we're ready to run the thermal model. Switch to the Models tab and then save your progress. Click Submit Job and then click Yes to write the input file. You can cancel out of the DANTE Model Builder for now. To view the model, click File and Open, and then filter by ODB files. Select the newly created file and then click OK, and the module should switch to visualization. Click Plot Contours on the formed shape to check results, and then set the output variable to SDV hardness. Before we get started on the next model, we need to close the current one. So press the plus icon to expand output databases, and then right-click the Open ODB and click Close. Now I'll start creating the stress model. Reopen the DANTE Model Builder and enter a new name under New Model Name. I'll name this one Aluminum Tutorial Stress. Click Convert to Stress and click Yes, and the module should switch to Mesh. Change the active model to the new one if it's not already set, and save your progress. Select Mesh and click Element Type. Box select the geometry and click Done. Select Axisymmetric Stress for under family and uncheck Reduce Integration in the Quad tab. Click OK and Done. Switch to the Initial/Boundary Conditions tab and click Add Displacement Boundary Condition. Set to fixed Y node, and then check U2 and click OK. Now to run the stress model, switch to the Models tab and then save your progress before hitting Submit Job and then Yes to the input file. Click File Open and filter by Output Databases. Select the new ODB file and then click OK, and the module should switch to visualization. Click Plot Contours on Deformed Shape to check results, and then change the output variable to SDVAL yield. Make sure to save your progress. And that concludes another Dante tutorial. If you have any questions or have something you want simulated, feel free to comment down below or send us a message at support@dantesolutions.com. Thank you for watching and happy simulating.